Welcome to R&R. Today we're going to be making a game from scratch. We're going to customize it all. We're going to be able to put your own sounds, your buttons, and here's what you need. You need your ISD 1820 voice recorder. You need a 4x4 membrane matrix, 25 LEDs, 5 different colors. You also need a 16x2 LCD display, 25 to 20 ohm resistors, 25 LEDs, and Arduino Mega, 5 different color LEDs I chose. Here we're putting the resistor on the short pin of the LEDs. That is very important. And make sure you put the other end of the resistor on the negative of the breadboard. Make sure to take your time and be patient, and you can see because there's a lot of little holes on the breadboard. Here we're adding another piece of breadboard because I realized that my cable management was going to be a disaster. I like to use double-sided tape to help with my cable management. It's really easy to use and really important to really know where your cables are. Here we remove the little film protecting the tape and we start laying down our cables. Here we are running the lines to the long pins of the LEDs, and as you can see, I am using a tiny flathead screwdriver to help me push in the tips of the cables into the little pinholes. It's a little hard to do it with fingers if they can't fit in the space. We repeat the process 5 times here, once for every color. Make sure you stay organized. We are going to program these LEDs, so you have to know where they are exactly. So that's why cable management is super important. If you like what we do, subscribe to our channel and follow us for more exciting content. Once we are done running all those cable lines, we make sure that we check our setup, make sure we didn't pull anything out. And here we start connecting the clusters of cables. Again, I am using the little screwdriver because putting in a lot of pins is hard. Our blue pins are going to be on 22 through 26. Our pink ones 27 through 31. White are going to be pins 32 through 36. Yellow 37 through 41. And our red ones are going to be 42 through 46. We like to use electrical tape to cluster the bundles together. So that way, if something happens, we can track it super easily. Here we do another inspection, make sure that everything is okay. We move on to the 4x4 matrix membrane. We connect it to pins 47 through 53 and A0 on the Arduino board. As you can see, I added extenders. I don't like to have tension on my cables, and extenders of the same color just makes everything super easy. We do one final check on the setup, add electrical tape, and bam, looks good. Here we are connecting our 5 volts and our ground to our breadboard from our external supply, and we connected a shared ground. We test our matrix: 4 blue, 5 pink, 6 white, B yellow, and 7 red. It works. Here we move on to the 16x2 LCD. We connect our VCC to our 5 volts, ground to ground, SDA to pin 20, SCL to pin 21. We are going to run power and ground through the external supply. Here we make sure everything is connected okay. We move on to our 2 push buttons. These buttons are going to be connected on A0 and A1. We connect them to a shared ground. We inspected. So as you can tell here, our matrix board is connected to pins 2 through 9 in the Arduino now, which is how and why we can connect the buttons to A0 and A1. We test our matrix. It's working fine. It's triggering everything. But after all of this, I decided to change my mind and use push buttons. So we go ahead and say bye-bye to the matrix. We readjust, we move our buttons down to the center of the breadboard, which we have to run new cable management. We move the line cables that go to A0 and A1. We connect our ground, but we add a little tape to make sure the cables stay down. We connect them both to a shared ground, and we decide to test the cables, make sure they work, and it's triggering everything fine. And finally, now we can add our cool, colorful buttons now. So much better than the 4x4 membrane. We replaced the LEDs to match the button. Now we have green LEDs. We run our cables and we run them to the Arduino pins D2 through D6. We color match the cables to the buttons. And here we do our grounds. It's a little complicated here because we hadn't ran our ground to that part of the breadboard, so we had to do that. And it looks good. It's a little tight, but it looks pretty good. We take the other ends of our buttons and finally put them on pins D2 through D6, and we inspect everything. Everything seems to be working fine. Once we test it and the lights light up, the buttons push and light up, and everything is working cool. I am very happy. Here we move on to the ISD 1820. We connect our VCC to the 5 volts, ground to ground, PE to pin 10, and record to pin 11. We add our 5 volt line to the breadboard and our ground to make sure that the buttons can get that ground. We connect our module to pin 10 and 11. We take a look at it and we can test it.
Wrong. You suck.
We record and it's time to practice, time to test it. We're going to win and then we're going to lose on purpose to hear the speaker. Let's see what happens. Everything seems to be working fine. We're going to go ahead and add a buzzer. We connect it to our ground and the positive end, we go to D47. This is going to give us auditory feedback. We're already getting visual with the lights. We make sure that it's connected okay. We connect our USB to our computer. Finally, open up Arduino IDE, make a new sketch. We paste the code that we have worked on. It's a lengthy code. If you want the code, message us. Upload the code. Once it uploads, you're going to hear it and you're going to see that it's ready to play. Thank you for watching. Follow us and subscribe if you like what we do. Thank you for taking the time to watch our videos. Thank you very much. We love doing this, and your subscriptions really truly do help get us to the next level. Thank you.